Okay, so the following scatter plots are sample data. We need to match each scatter plot with the best description below. The scales are omitted intentionally. So if I look at my graph on number 1, it says X represents the month number and Y represents the average temperature in Boston, Massachusetts. Boston has cold winters and hot summers. So if I have it cold in the summer, so that's going to be this one because I have it cold in the summer. So my temperatures are going to be low, and then it's going to get warmer, then it's going to get cold again in the summer. So that's going to be D. And then X represents the 5-year increments from 1955 to 2015, and Y represents Medicare expenditures in the US. So this one says, and the increase gets bigger every 5 years. So that one's going to be B because it says the expenditure gets bigger every 5 years. So if it gets bigger, it's basically going to multiply, and it's going to get bigger. So that one's going to be B. And then X represents the average outdoor temperature and Y represents the cooling costs of a home. So basically, if it's cold outside, that's going to be this one. If it's cold outside, you're going to have no cooling costs basically because you're not going to have the air conditioner on. But when it's 100 degrees outside and it's hot, you're going to have high cooling costs. So this is going to be my graph. The hotter it is outside, the more your cooling costs are going to be up. So that one's going to be A. And then for the last one, X represents the engine size and Y represents city miles. So for this one, if you have a small car, you're going to have high miles per gallon. But if you have a big truck, you're going to have low miles per gallon. So that one is going to be C. That's going to be this one. Okay, scatter plots are a primary tool in statistics used for examining two variable numerical relationships. When you see a scatter plot, ask yourself, what are the two variables being measured? What does each dot represent? So your two variables being measured are these things that are along your axes down here. Researcher poses the following questions for observational study. Is there a connection between the typical marriage ages for men and those for women in the United States? The researcher records the median ages for men and the median ages for women for each state, Washington, D.C. and the data are shown below. And so this graph they call a scatter plot because basically you just have a bunch of dots. So they basically took every state. So all these dots basically represent a state, and they took the age of every man and every woman and they put a dot where it was. So like, for example, like this is a dot for a state and whatever the age of a woman was and the man was, and they put a dot where it was. So each one of these dots represents a separate state. Okay, it says, why did researchers choose the median as the best numerical measure for the data? So they chose the median. Because you would expect the data to be skewed because more people, with more people getting married in their 20s, because most people get married in their 20s and some in their 30s, but looking from this chart, most get married in their 20s. Okay, so here they want your input variable. So in this case, the input variable from this chart is the median age. This one, the median age for, the median age, median age of marriage for women. And then the output is the median age of marriage for men. Let me make that F a little bit nicer. Median age for men, that's your output. So if I want to know if part D, if these are numerical or categorical, they're both numerical because they talk, oops, that's an A, because they talk about ages. Let's fix that a little better. They're numerical because they talk about ages. And it says, what does each scatter plot or each dot represent? So basically it represents the median age of a man and a woman for each state. So basically each dot represents a particular state. And then the states in which the typical ages for both men and women are the youngest are in Idaho and Utah. What is the typical age for men and women in those states? So if you look down here, that would be these ones down here. And so that looks like your typical age. That looks like it's about maybe like for the age for women. So women are down here. So that looks like that's about maybe about 23 years old. It says the state in which the typical ages for both men and women, and the oldest state is Washington, D.C. What is the typical age for men in this state? So this is the oldest. So for men, that's over here. So that looks like that's probably about maybe 30. Oh, maybe that's a little high. So maybe I'm going to say maybe about 30 years old from the looks of that, if I'm trying to read the chart. I can't really draw very well, but I would probably say 30, 31 years old. Okay, so next we're going to look at trends. The trend of an association is the general tendency of the graph as you scan from left to right. So we're going to kind of put in a general line if you can. So the trends that are increasing are called positive associations or trends. Trends that are decreasing are called negative associations or trends. Answer the following questions about trends below. So if I kind of draw in a line, so I kind of have, even though the points are going straight up, I kind of have a general trend. So here my input variable is fat in grams. And my output variable is my number of calories. And then my each dot, get a different color. So my each dot basically represents a cereal brand. Then it says draw a line to show the curve or show the trend in the graph. So I did. About half of the dots should be above the line, half below. Is the trend positive or negative or either? So this is a positive trend because all of your data are going up to the right. So if there's a trend, explain in the context what the trend shows. So at this point, when I want you to write a sentence, when I want a trend, you're basically going to write it as the input, whatever the input is, increases, the blank, whatever the output tends to do this. So when I want you to write something about a trend, you're going to write it like this. So as your fat, so as your amount of fat increases, your number of calories tends to increase. So when I ask you for a trend, you're not just going to say my trend is positive. You need to be specific and tell me as this increases, or as this increases, this decreases. You need to be specific. It needs to be in a sentence. Okay, so the next one, it says my input variable, again, is my vehicle weight. So this is my vehicle weight. And then my output variable is going to be my mileage, my miles per gallon. And then each dot basically represents a vehicle. So whatever vehicle it is. It says draw a line or a curve to show a positive or negative trend. So I'm going to try to draw it. So there's about half of them above, half are below. This is a negative trend. And it says basically as your vehicle weight increases, so your vehicle weight is always going to increase. So we're always going to say increasing for that. Your mileage is going to tend to decrease. That is our basic trend. Okay, so on this one, our input variable is time, and that's in hours. Our output variable is age in years. And each dot, we didn't really specifically say what this was. We're just basically going to say this is a person. We don't know if this is people or animals or whatever it is. But this one, you notice that you have dots everywhere. You can't really tell if it's positive or negative. So basically this has no trend. So if this has no trend, you don't fill this out. You can't basically tell me a pattern. So you don't need to do that part. So this has basically no pattern. So it's not positive or negative. Okay, so now we're going to talk about shape. So for now, we're going to classify scatter plots as linear or nonlinear. So our trend, a trend is called linear if it can be summarized by a straight line. So if I can draw a straight line through it, and generally you've got about half your points above or below. In general, it increases at the same rate. So if it looks like it's going up the same slope. So I want to draw a line or a curve through the graph. Again, about half the dot should be above or below. So you can see on the graph on the right, this one looks straight. This one more looks like this should be curved. So we're going to call this one nonlinear. We're going to call this linear. So that's the only two classifications we're going to do for these. It's linear or nonlinear. Okay, next we're going to talk about the strength of your scatter plot. So we'll describe the associations as weak, moderate, or strong. So weak basically means that all of your scatter plot points are, so basically like if I had a line, they're going to be separated like far apart. So this is what weak would look like. They're basically all separated far apart. Moderate, they would be closer together. This is moderate. And strong, you should see that the points are, let me do it over here. So for strong, you should see that they're close to it. This is strong. Let me erase this one down here. So for strong, they should be close together. So weak, they're spread far apart. Moderate, they should be kind of in close. And then strong, they should almost be on the line. So weaker associations have a larger amount of scatter above and below the line. Stronger will better fit the shape with less scatter above and below. So they want you to draw a trend line for these ones. So if I draw a trend line, and then it says write a sentence comparing the strength of the woman's height versus her brother's height and her mother's height. So if you compare the two, okay, this one has stronger, this has a stronger strength than this one. So the women's height, so the woman's height has a stronger association with the mother than the brother, because you can see than the brother's height. Women's heights have a lot closer because this is stronger and this is more moderate. So the mother is closer than the brother. And then again, here's one last one. Here's that serial one again, where we put the line in here. And this one, you'll notice that all of your dots are getting far away from this. So this, we basically say, is a weak positive linear association. So it's weak because they're spread out far apart. It's positive because it's going up to the right. You can still draw a linear through it, but it's basically weak because they're spread out, spread far apart. They're not close to the line.